As Earth continued to spin rapidly with 6-hour days, and the Moon gradually drifted farther away, a silent but profound transformation was unfolding. The collision that created the Moon not only slowed Earth's rotation over time, but also permanently altered the planet's orientation in space. That change, subtle at first, was monumental in its consequences. It tilted Earth's axis. Because of this tilt, Earth's axis now leans at approximately 23.5 degrees, and it is this slant that gives us our seasons. Without that tilt, Earth would spin upright, like the planet Mercury, and every region would receive 12 hours of daylight and 12 hours of darkness. No spring, no summer, no autumn, no winter. The poles would remain trapped in an eternal whoosh, while the equator would roast endlessly under the unrelenting heat of the sun. Life, as we know it, diverse and seasonal and dynamic, might never have evolved. But even more critically, the Moon acts as a stabilizer. Astrobiologist Lynn Rothschild explains that without the Moon, Earth's axis would not remain fixed. Our world would experience what scientists call chaotic obliquity, wild fluctuations in axial tilt, ranging from 0 to 90 degrees. These erratic swings would redistribute sunlight drastically across the globe, plunging tropical zones into icy winters and pushing polar regions into scorching summers. This kind of chaos would devastate ecosystems, trigger mass extinctions, and prevent the long-term stability needed for complex life to flourish. It's the Moon's gravitational pull, functioning like a global gyroscope, that dampens these swings. Thanks to this celestial stabilizer, Earth's climate patterns, while not always gentle, have remained relatively predictable over geological timescales. To understand how critical this is, consider Mars. The red planet also has seasons, but they are wildly inconsistent. Mars has two tiny moons, Phobos and Deimos, which are too small to stabilize its axis. As a result, its tilt has shifted dramatically over millions of years, swinging between 15 and 45 degrees or more. Scientists believe this instability is a key reason why Mars, though it may have once had liquid water and perhaps primitive life, failed to sustain a biosphere like Earth's. So, while Earth spins on its tilted axis, the Moon keeps that tilt from tumbling. But the Moon's influence doesn't end there. Its gravitational dance with Earth also plays a pivotal role in one of the most life-sustaining processes on our planet: the tides. Billions of years ago, when the Moon was still closer, its tidal pull was much stronger. Tides then were nothing like the gentle rises and falls we experience today. Instead, they were colossal, towering thousands of feet high, capable of surging inland for hundreds of miles. They roared across the planet with the power of a liquid mountain range, dragging surface minerals and sediments back into the sea. Astronomer Neil Commons studies how these early tides may have catalyzed the chemical complexity necessary for life. The immense mixing action churned nutrients and minerals into what scientists call the primordial soup, a rich, volatile ocean of chemical reactions. Molecules were bound together and pulled apart again and again until eventually the first building blocks of life, proteins, amino acids, RNA, began to emerge. Some researchers even believe that the Moon's gravitational influence might have helped spark the earliest replication of DNA. As tides surged and receded, they could have altered chemical concentrations on ancient shorelines, encouraging the separation and rejoining of primitive strands of genetic material. Without these fluctuations, it's possible that life on Earth would have remained simple, or never begun at all. And these tides had another hidden benefit. They helped calm Earth's atmosphere. In the chaotic early days, Earth's faster rotation and short days generated constant hurricane-force winds. With a 6-hour day, wind systems circled the globe with terrifying speed and violence. Today, hurricanes may last a few days and travel a few hundred miles. Back then, hurricane-like conditions would have been perpetual. These winds made Earth a hostile, unlivable world. But the friction caused by the moon's tidal forces gradually slowed Earth's rotation. As days lengthened from 6 to 8, then 12, and eventually to 24 hours, the winds also lost strength. The atmosphere began to settle, and weather systems became more temperate. The moon's gravity not only gave Earth seasons and tides, it pacified the climate, allowing life to evolve beyond single-celled organisms. In a sense, the moon didn't just accompany Earth through the ages, it parented it. It helped craft a world that could nurture forests, oceans, animals, civilizations, and eventually, consciousness itself. Our relatively calm Earth, with predictable climates, stable seasons, and manageable weather, owes this gift not just to its position in the habitable zone of the Sun, but to the steadfast presence of its moon, a cosmic partner that may have made life not only possible, but sustainable.